Welcome to this break session, Cloud Protector, Security and Optimized TCO, how a WAF as a service enables a smooth digital transformation, and it's with Alexis Zourabishvili right now.
Thank you, Alexis, and hi everyone. Today I will introduce you during this breakout session with Cloud Protector, our WAF as a service, how this WAF as a service enables a smooth digital transformation with a security and optimized TCO. First of all, your application security challenges. So you can find here on this slide the need of combining security and low false positive rates. Integrating security in production often leads to fear of inappropriate blockages. The second point is covering hybrid environments. Indeed, you can have on-premise application, but also cloud application and third-party provider application. So the security solution must be able to provide an homogeneous level of protection to heterogeneous environments. The third one is to limit configuration and deployment load. The lack of human resources and the high impact of integrating a solution is a major obstacle in order to deploy it and to integrate it in an IT. And the fourth, the patch vulnerabilities in production. External web applications present a high level of risk, with 35% of the vulnerabilities discovered in 2019 on the various CMS classified a high or critical risk compared to network layer system exposed on internet, with a high or critical risk level of only 5%. So it's a major issue on web application. And it takes over a month for the average organization to patch its most critical vulnerabilities on web applications, according to a recent report. It hence the need to patch immediately before the vulnerable application. And that's why updating an application to address a vulnerability issue can cause side effects and therefore impact the business, and we need to address it before with, for example, the web application firewall. So in order to present you how Cloud Protector will address the security issue of your web application and protect you directly, you can find here the legitimate user who is attempting to access to the website and the hacker. The hacker will be blocked directly by Cloud Protector, and the deployment of Cloud Protector is very fast. After a DNS redirection, your website is protected. So we'll now together take a look of Cloud Protector web interface. So you have to log in with your credential. Even your password is not shown here. And directly you will see the web interface with all the menus in order to set security, etc. But we'll now focus on manage websites with website creation. So you have to to enter the label of your website, the name, and after the FQDN in order to set it. And just before that, you have to set your server URL backend, which is automatically detected in this case. Now you can click on set, and that's all. Your website is directly protected. You have just to configure your DNS redirection. Now let's have a look on the architecture of the service. You have here the visitor using internet through a DNS in order to access to the web server. And the DNS will say you have to pass through Cloud Protector, even it's transparent for the visitor. Cloud Protector is hosted on a provider with anti-DDoS, which is volumetric and applicative security. And you have load balancers and WAFs. The WAFs are addressing the common traffic, and you can have scaled WAF on demand and automatically when you reach a peak. Also, the deployment could be hybrid with on-premise, public cloud, or third-party host. When you have a peak of traffic and a DDoS, there is a health monitoring which can directly address a DDoS issue and to provide another DDoS protection with another provider. In a few minutes, you will directly be protected by this second DDoS protection. The users can directly use the GUI in order to provide new website security, configure it, and automate it. That's on this third point, we will have a look on the use case of virtual patching. So we'll now watch how to patch a new CVE with the WAF in SaaS. So why virtual patching? You can see now the objective. Virtual patching is the process to add blacklist patterns specific to your application, mainly in two scenarios. Your application is vulnerable to a brand new CVE that is not covered by the default security engines. You need to patch the vulnerability until it's covered by the updated engines provided by Rode Schwartz. Or you are using a bug bounty program and Hunter discovered a vulnerability that is not yet protected by Cloud Protector. And this process can be done manually using the GUI, but this is interesting to industrialize it using the API in some cases. For example, you have plenty of applications to patch and you need a tight integration with your bug bounty program. So the process can be carried out manually using the interface, but can also be industrialized via Rode Schwartz Cloud Protector API. So now let's go deeper in this specific use case. Finding specific patterns to block it sometimes is difficult. Rode Schwartz experts can help to get the correct pattern to configure. Just open a support ticket. For this example, application is vulnerable to the CVE 2020-7961. After analyze, the exploitation of the vulnerability can be blocked by detecting a specific pattern used to inject the attack payload, as you can see here. Since many applications are affected, you need to industrialize the deployment. First step is to create my API key with enough permissions. From the API documentation, I need the auth act update website action to manage the website blacklist, as you can see on the illustration on your screen. Rode Schwartz can provide a Python SDK to ease the API usage, especially the authentication of the API calls is not straightforward. Once configured, using the API is fast and easy. Just call the correct endpoint with parameters, and that's it. The API is provided with a complete documentation of the endpoints and parameters, as you can see on this example. So I'm here on the security setting panel of my application, and I currently have no blacklist rules configured. And since a CVE has just been made public and touches one of my applications, I'm going to use the API to automate the process and deploy this virtual patch in a few seconds. This is also something I could do for a lot of applications. So I'm using a very simple script built on the Python API that includes some parameter processing and a call to the blacklist API. The script will take a few parameters, the first of which will describe my application. The provider name and the tenant name are always fixed. The server name will be used to designate my application to apply the desired blacklist rule. And the 4 following parameters will correspond to the blacklist parameters you want to insert. So in order to retrieve these first 3 parameters, we have designed this in a very simple way. Since you just have to find in the URL the 3 parameters separated here by slashes that I just have to copy here in my command line. Okay, so this will give us this with the description of the rule of my blacklist and my pattern. So I want my pattern to be key sensitive and applied to the body. You have the choice between the body or the header. And after I have to validate, and the rule will be instantly created. The ID of the rule has been generated in parallel, that I can, of course, reuse to remove this rule from the blacklist, for example. And now If I go back in the interface, I refresh, and I see my new pattern that has been added. Magic. I can of course go and modify it if I want, and I find my key sensitive pattern that applies to the body with what I filled in the input. To conclude, let's go back to our objective, which is how to lower the TCO and increase the security level. You can see here, the first is an optimized infrastructure cost. Indeed, the advantage of this pricing model is that your expenses can be classified as operating expenses instead of capital expenditures. The initial investment is minimal and easy to predict. You avoid unforeseen material and maintenance costs. All hardware, backup, and maintenance are managed by the vendors. Secondly, you can immediately address a peak of traffic on your application and protection against volumetric or applicative DDoS attacks. Thirdly, answer to the OWASP top 10 and get immediate deployment in a few minutes. These are the 4 things to lower the TCO and increase the level of security. Thank you very much for your attention, and I now invite you to have a look on the other breakout session. Bye.